Hello, and welcome to video number 3. Today we're going to talk about the energy for muscle contraction. So over the last couple of videos, we talked about the type of muscle cells, which were cardiac, skeletal, and smooth. And then we talked about in the last video how a muscle knows what to do and it gets its signal from the nervous system and it will contract. And I mentioned this thing called ATP, and that's the energy that is needed to do a muscle contraction. So now, today, we're going to talk about where that energy comes from. So just kind of little background, I'll draw a little picture up here that you have a molecule called ADP. Now, many of you may hopefully remember what it is, but you might not. So ADP is adenosine triphosphate. So the way I kind of draw it is kind of just draw the adenosine, and then it's got what's known as a diphosphate. So it's got 2 phosphates. Well, ATP has 3. So what you're going to do is you're going to take ADP and you're going to add a phosphate, and through a series of reactions, and again, it's done 3 ways here, but what you're going to do is you're going to make ATP. Now, ATP is going to be that adenosine, and it's going to have 3 phosphates. 1, 2, 3. Now, there's a lot of energy right there in that bond. So I'm going to use the word hydrolyze. And whenever you hydrolyze something, you break something. So when I hydrolyze that bond between the second and third out phosphate group there, it's going to release some energy. Well, what's going to happen is when I release that, I'm going to be back down to an ADP, and the P is going to be released. Well, how do I make ATP again? Well, I got to put the phosphate back on. And that process of breaking and making happens all the time. So we're going to talk about 3 ways to kind of make ATP. We're going to talk about one that's very, very, very efficient, and that's going to be your aerobic. But we're not going to start with that one. We're going to start with the first one called direct phosphorylation or creatine phosphate. So let's get rid of all that, and let's see what we got. So ATP is hydrolyzed to release its energy. Once again, hydrolyze means to break that last bond between those last 2 phosphates. And that is going to turn ATP into ADP, which we just talked about. A muscle has 4, 5, 6 seconds worth of stored ATP. So in essence, you should technically be able to do anything for about 4 or 5 seconds. But in some cases, when you exhaust that ATP, if you don't make it fast enough, you will be, in essence, exhausted, or you will have what's known as muscle fatigue. So you got 4 to 6 seconds stored. And I'm going to teach you about 3 pathways that are going to help to regenerate ATP or to make ATP from ADP. And in order to keep moving, you need ATP. So let's talk about the 3 ways to do it. The first is called direct phosphorylation, which is very simply taking a phosphate from one molecule and adding it to an ADP. So let's take a look at this one. So you have this thing called creatine phosphate, which is a creatine molecule with a phosphate on it. I'm going to shorten it down to CP just so we don't have to keep on saying it over and over again. Now, CP or creatine phosphate is stored in the muscle cell, and it's going to help turn ADP into ATP, which is great. It's going to happen super fast. So again, when you need it, it's available. Fraction of a second, quick. Now, the muscles, which is kind of cool, are going to have, hopefully, a lot of CP laying around because, again, if you need to do what you got to do, it'll be very helpful to have more creatine phosphate than ATP, which is great. But again, however, not good that if you're not careful, in about 20 seconds and you lose all your creatine phosphate, well, now what? So again, the body has ways to get more ATP, but in this case, 20 seconds now is good to hopefully get you out of whatever situation you need to get out of. Now, what's going to happen is, when I show you the picture, you're going to make a 1-to-1 ratio. So 1 creatine phosphate will help you produce 1 ATP. That's important. It is a 1-to-1 ratio. And you're going to see, let's kind of get rid of that because I believe there's going to be something down there on the bottom. You're going to see, in this case, good for you, that oxygen is not used. So you do not need to even breathe to do this, which again is good. If you need that quick burst, that 10, that 15, that 20 seconds of energy, and whatever, let's say you're not taking in oxygen. If you watch some of these crazy Olympic 50-meter freestyle swimmers, they'll hold their breath, but that 50 meters is done in like, I don't know, 15, 20 seconds. I mean, it's crazy how fast they can swim that. But they're holding their breath and not bringing in any oxygen, but they can still make ATP with the help of creatine phosphate. Good for them. So take a look at this little picture here. The energy source is the creatine phosphate. And what's going to happen is you're going to take the creatine phosphate, which in essence is creatine with a phosphate on it. You're going to take the phosphate from here. You're going to donate it to ADP, and then you're going to make ATP. So now this has 3 phosphates again. Well, now you got a creatine all by itself. There'll be a separate process that will do this, but again, we're not interested in that in this particular chapter. Taking a look at some of our information here. No oxygen needed, check. It is a 1-to-1 ratio, check. And it lasts, once again, 15 seconds or so. So that is what is known as direct phosphorylation. Aerobic respiration, that's what you guys do all day, every day, as long as you've eaten and you breathe. So you're going to need 2 ingredients, oxygen and glucose. Okay, that's cool. But good, luckily for us, we get a ton of glucose in our diet. In the event that we don't eat it for a while, our liver is nice enough to store it for us in the form of glycogen. So we're looking good. So all things, we're pretty good deal on aerobic respiration. So here, you're not going to use direct phosphorylation. You're going to use something called oxidative phosphorylation. Now, again, this is a very complicated process that's not for this particular topic. But what oxidative phosphorylation simply means is you're going to turn ADP into ATP just like you did before, but now you need oxygen. And it's going to happen in the mitochondria. And again, it's a pretty difficult pathway. We're not going to get into that here. We just need to know that oxidative phosphorylation happens in the mitochondria, and it's going to allow for you to put the phosphate group on the ADP. And this is going to happen great during normal muscle activity, walking, hanging out, even light exercise. You'll be fine. Once you start doing strenuous exercise, then things get a little difficult, and we'll talk more about that when we switch over to the third choice of phosphorylation. But for right now, light exercise, maybe you're doing some light aerobics, maybe you're jogging a little bit, you're not going crazy. You're breathing, you've eaten, life is good. You're doing what's known as aerobic cellular respiration. You need some glucose, once again, so you ate. Maybe you had an energy bar, maybe you had a cereal, oatmeal, whatever. You ate something, you're breathing, you're not huffing and puffing like crazy. And what's going to happen is you're not going to make 1 ATP, you're going to make 36 ATPs. Your body's very, 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 going back to my smiley face, happy. Now, again, it's slow. All things take a fraction of a second, so it's slower than that. And you need oxygen. And what it's going to do is it's going to release CO2, and it's going to release some water. So this formula is going to take in 2 things. It's going to take in oxygen, and it's going to take in glucose, and it's going to produce CO2, H2O, and very importantly, ATP. So if you look at this formula, oh, scratch that, I forgot to tell you, of course, oxygen is used. It's oxidative phosphorylation. Can't do it without oxygen. So now take a look at this. Now this looks crazy, and I understand that. But again, you don't need to go bananas with this yet. What you need to know is that is your mitochondria. And your mitochondria are found, you have lots of them in each one of your cells. You're going to put in your glucose, there's that. You're going to put in your oxygen, there's that. And you're going to get out 3 things. CO2, which is a waste, you're going to breathe that out. Water may leave in the form of water vapor when you breathe. And ATP is what your body's going to use big time. Well, let's see. Do we need oxygen? Yep. But we're not making 1 ATP. We're making 36 of those babies. And what's nice is if you're careful, you can do whatever you're doing for hours and hours and hours. Now, if you're doing a long event like a marathon or something crazy like that, you're going to want to be taking in glucose along the way. Now, I'm not saying stop and get a hoagie or eat a loaf of bread. You want to take glucose style tabs, or you want to take these various kind of energy things like goo or whatever. But if you can get the glucose in and you breathe and your body has been trained, you will finish that marathon. And then, unfortunately, you may push yourself to the limit, and this will happen a lot of times with, let's say, the first day of practice, when you took off a season, like maybe basketball or football or something where you got to do a lot of running. Well, you were asking a lot of your muscles, and maybe you didn't get enough oxygen, or maybe you didn't eat enough glucose, or whatever. And now your body's like, yo, we need some ATP, and we're going to do it at a cost. Now, this is called anaerobic respiration, which means lacking oxygen. But unfortunately for you, you're going to produce lactic acid, which tomorrow, my friends, is going to hurt. And anyone that has been sore the day after, let me explain how it happened. You ate, you had some glucose, maybe you didn't eat, but you broke it down from your glycogen, whatever. But you didn't get enough oxygen into those cells, into that mitochondria. But you still needed energy. So your body's like, all right, we can do this. But instead of making 36 ATPs, you only make 2 for every glucose. Very inefficient. And for you, the problem is going to be later when you produce lactic acid. So you're going to make this thing called pyruvic acid, which we talked about. Well, I showed it to you before, but you don't need to know that for this class. And what's going to happen is you're going to once again, with the pyruvic acid, if you made it, it's going to go aerobic, which is great. Or, in this case, not aerobic because you don't have any oxygen available or not enough. And you are going to make this very, very, very painful thing tomorrow known as lactic acid. And that's going to lead to potential muscle fatigue while you are practicing and definitely soreness tomorrow. So let's say, I don't know, you're crazy enough to make a bet with your friend and say, I could do 100 push-ups or whatever, and you just start going crazy. Now, you haven't done a push-up in, I don't know, like a year or something, whatever. So you start doing these push-ups, and you think you're hot, and you think you're awesome, and then by around 20-something, you really feel like, hey, this isn't going so hot. And you maybe push out 1 or 2 more, and next thing you know, you just fall flat down, chest and face first. What you did was you went into a mild form there of muscle fatigue. And what happens there is your muscles for that small amount of time said, sorry, bud. And they just, in essence, quit on you. Now, all along, before they quit, you started to make some lactic acid. So tomorrow, when you wake up, you are going to be sore. So many of you, I'm sure, have experienced that. And since it's anaerobic, that means no oxygen, and oxygen is not used. So if we take a peek at our, what's going on here? Take a peek at our picture there. We have our glycogen / glucose, so we got that. Once again, no oxygen because we don't have enough. And there's our very painful lactic acid that builds up. So once again, our energy source is still glucose, which is cool. No oxygen. And you don't make 1 ATP, and you don't make 36 ATPs, you make 2. And that, lactic acid. And in this case, you're down to only a few seconds, and that's why you're doing your push-ups. And after, I don't know, a minute or so, when you go face first into the ground, is because your muscles at that time were in oxygen debt, and, well, they failed for just that time. But the good news is your life is not over. If you rest and you breathe, you will recover. So please don't think that muscle fatigue is the end of your life, because it's not. So what happens here is in muscle fatigue, let's say you think you're slick and you're doing all these push-ups, the muscle is unable to contract anymore. Even though your brain's like, come on, you can do this, you got this, push, push, push. Your muscles are like, sorry, bud, can't do that. So that's what muscle fatigue is. And again, oxygen debt, we talked about that already. And it could possibly happen in a marathon runner that did not train properly. And when you do not train properly, you will see sometimes in the videos where a person will be running and they simply fall down flat on their face. And it's pretty scary, actually, if you've ever seen somebody do that. Now, again, they will be able to walk. Their life is not over. But for that small amount of time, they experience muscle fatigue. And you can reverse it with rest, like stop running, proper breathing. You may need to get an IV. You may need to get more fluids back into your system. So lots of things will happen to these endurance athletes that are not trained properly and overdo it. So don't do that. And the muscle contractions themselves, let's assume that we're contracting fine and life is good. We have two kinds of contractions. We have what are known as isotonic contractions, and we have what are called isometric contractions. Now, you want to be careful when you do your work on this that they sound very similar, but they're not the same. So, for example, in an isotonic, what happens is your muscles shorten as you are contracting. So, for example, if you bend your knee, if you bend your arm, if you are writing, anytime you are moving, you're actually moving, you are doing what are known as isotonic contractions. The muscles are actually getting shorter. So walking, running, riding a bike, aerobics, whatever. Now, isometric contractions, that's a different story. There, you are trying to contract your muscles, but they're not shortening. So, for example, if you try to push into a wall, let's just say, you will be sweating and you will be sore and your muscles will be trying to contract and you're trying to move that wall, but the muscles are not shortening. Now, is there value in that? Yeah, sure. That's how you get stronger, by doing isometric contractions, pushing against, let's say, a huge force that takes a lot of effort. And again, if you try to pick up 400 pounds, I'm going to guess most of you cannot do that. So you will try and you will be sweating and you will be grunting, but your muscles are not contracting. So if we look at these fine pictures here, this would be our isotonic. And once again, you can see there that that person is bending. And this is going to help build up endurance. So for example, things like marathon running and long distance bike riding and so on. This would be your isometric, and what this person is doing is they are pushing against a lot of weight. And they are pushing. And maybe they'll get that weight up, maybe they won't, who knows? You got 3 people helping them. 1, 2, 3 over here. So kind of really doesn't count. But if you do enough isometrics, that will help build strength. So what did we learn here? We learned about energy, how we can basically create ATP, which will give us the energy for our muscle contractions. We learned what happens if we run out of oxygen at that local level. We'll go into what's called muscle fatigue. And then as muscle contractions go, an isotonic would be movement of something, like in this case, bending down. That's going to build endurance over time, running, bike riding, aerobics, things like that. And then isometric is you are contracting the muscle, but the muscle is not shortening, and that will help build strength over time. So day 3 is done. We got 1 more to go, and the muscle system will be complete. See you soon.